C of Module 2, Principles in Computer Design. Part C.1, Introduction to Principles in Computer Design. Yeah. So in this part, actually, or in this, our first video, I want to give an overview. Actually, this is an overview of this whole class, because these principles we will learn actually cover the most important topics for this class. So let's look at these principles. There are 3 principles in computer design. Actually, computer system design. Yeah. So for this whole class, the key part, these 3 principles. Yeah. The first principle, it's called taking advantage of parallelism. Here, the main keyword is the parallelism. The goal is very simple. In order to get a better performance, faster, better performance, we try to explore as much parallelism as possible. And here, the main topic for this class, we will study this instruction level parallelism. There are several different types of parallelism, but our main focus is instruction level parallelism. When CPU executes long sequence of instructions, in order to make the overall performance faster, we want to explore as much parallelism as possible during the execution. Yeah. But this part, this is a big topic. This part we will learn after midterm. After midterm. After the midterm, the main topic, almost all the topics belong to this category. Yeah. Other than the instruction level parallelism, there is another type of parallelism that many of you heard of that. Yeah. Processor level parallelism. Processor, multiprocessor. Yeah. So right now it is very common. So many CPU using that multiprocessor architecture, multi-core, right? Multi-core, multiprocessor architecture. Now, so that is another big topic. Yeah. But for this class, we will not do that part. Yeah. Multiprocessor, that architecture still another big topic. Yeah. But we don't have that much time, so we will just focus on the instruction level parallelism. Yeah. All right. The second one, principle of locality. Principle of locality, another important principle. Yeah. So what's that? Yeah. Programs tend to reuse data and instructions they have used recently. Tend to. So here you can see first tend to. First it tells you, so this is some kind of a statistics result, based on statistics. Yeah. And approximately in this way, approximately in this way, but it happens most of the time. Reuse data and instructions. Another, data and instructions. All right. In order to execute all the instructions for a particular program, CPU needs to load data and instructions from main memory into CPU. All right. So now this phenomenon is critical. So reuse data instructions they used recently used, there is a trend to use these, data instructions repeatedly. So that's the principle of locality. Yeah. And this principle extremely important, because this principle, based on this principle, the cache technology was developed. Cache technology. Why the cache technology is so successful? Because of this principle. Yeah. And we will finish module 2 today. After that, we will start module 3. So this topic, we will use module 3 and module 4 to cover this topic. So you can see, so important. We will use 2 modules to cover. Yeah. This one even more, because after midterm, all the materials belong to that category. So even more important. Yeah. All right. Then the third principle, focus on common case principle. So this is another principle we can use to improve our overall performance of a program. Yeah. Focus on the common case. Yeah. So what do you mean common case? Yeah. We know. So that case happens more frequently. So that's the common case. So we should focus on what kind of thing you want to focus on. Common case. Focus our resource. In computer system design, our resource is limited. When we put our precious limited resource in selected parts, here this principle tells you it's better to put in the common case. Yeah, that makes sense. So that makes sense. Yeah. So this principle is the main topic of this part C. Part C of module 2. Yeah. Module 2. Yeah. So the current part that we completely talk about this topic. Yeah. All right. Yeah. In making a design trade-off. Yeah. So when you do system design, you need to make decisions. Sometimes the decisions related to trade-off. So you want to, improve this part, but sacrifice another part, right? It's a trade-off issue. So when you make a design trade-off, favor the frequent case over the infrequent case. The general principle. Yep. So if you follow this, you can use relatively less resource to do more improvement, more performance improvement. Yeah. To see that better, here I like to use our processor performance equation here. So this is the processor performance equation we developed in the previous part. Yeah. So here you can see for each operation there is some frequency number, right? Yeah. So a program can be divided into different operations. For each operation, there is a corresponding frequency. So the larger the frequency value, then we treat as the more frequent case. The smaller frequency number we treat as the infrequent case, less frequent case. All right, so now you imagine you have limited resource to spend over different operations. You may not be able to improve everything, right? You may not have that much resource. So you need to set priority, right? So with the limited resource, first, if we want to improve the overall performance, it's better to put that in the most frequent operation to improve that. Then your overall performance can be improved bigger. All right, so that's from the abstract discussion. But this part, we will derive a formula. With that formula, so you will see the formula will explain why we should do in this way to get a better result. The formula is pretty simple, but very important. So we can understand this principle much better. All right, so here you can see just this half of the slide gives us the 3 most important principles for this whole class. All right, now, so let's start a little bit, but the next half slide, I want to talk about a little more on this principle of locality. Just expand a little more. Then the remaining, so we leave to the module 3, module 4. All right. So what's the details of principle locality? So we want to see a little more information. The reason of success of the cache memory technology. The cache memory technology in computer history industry, the history of computer industry, it plays extremely important, big role because it improves the overall computing efficiency, performance greatly. Big improvement, revolutionary type improvement. Why it can improve the performance so much? Because this principle of locality. So so it is some statistics result, but it is true most of the time, and its impact is huge. Its impact is huge everywhere. So, all right, here I'd like to discuss 2 different types of locality. The first type called temporal locality. So based on time, temporal. So based on time-based locality. So that's the one we saw in the previous half slide. Temporal, that's the one. Temporal locality states that recently accessed item. So you see this recently. Recently refers to time, right? It happens recently. Based on time access, recently. Recently accessed items are likely to be accessed in the near future. Likely to be. So here you see another vague word, likely to be accessed in the near future, not long future, near future. Near future, this near locality. Locality with respect to time. Okay? That's the meaning of the temporal locality. Right? Yeah. So here you can see this is some observation. So people observed this phenomenon and then take advantage of this property in computer system design and enjoy huge success. Yeah. All right. But there is another meaning of locality. Yeah. Also important. Yeah. That's called spatial locality with respect to space. Space usage, space. Also very important. Yeah. So what's the meaning? The spatial locality says that items whose addresses, memory addresses, that's space, right? The addresses in memory. So that refers to space, not time, space, location in memory, yeah, are near one another, yeah, consecutive storage locations in main memory. So here we're talking about, addresses in main memory. All right, yeah. Near one another locality, right? Near one another. So that's a locality, right? All right. Tend to be referenced. Tend to be referenced. So there is this kind of statistics result. Tend to be referenced. Close together in time. Close together in time. Yeah. Recently in time. So, yeah. For example, all right. So let me just do a little more. All right. Suppose this data piece is referenced at the current time. Okay. So then the next time slot, it is very likely to reference this one. Next time, it's very likely to reference this one. Likely, yeah. May not be all the time, right? But that percentage to reference the, consecutive locations, very high. That percentage is very high. That possibility is very high. So that is the spatial locality. Both true. So you can see when some technology is based on this kind of locality, two different types. So you can take advantage of two different types of locality. Then the performance improvement is huge. Yeah. The biggest example is that cache technology. Cache technology. Although for the cache technology, this is big. Another is when you load the data, instructions, the program from hard drive to main memory, this principle is also used. So that is another situation we take advantage of this principle from hard drive to main memory. Hard drive, load data program into main memory. Yeah. To improve performance a lot. All right, so that's the discussion. In our first video, we just get an overview of the most important topics for this whole class. All right, so next we start our remaining part. We will learn focus on the common case principle. All right, yeah, so let's finish here.